Draw the graph of y equals 2x minus 5 for x is a real number between 0 and 5. Now, y equals 2x minus 5 is a straight line graph. We know that because the general form of a straight line graph is y equals mx plus c. So just looking at y equals 2x minus 5, clearly we can see that m, gradient, is 2, and c, the y-intercept, is minus 5. We are going to use the table method in this exercise, but a better method to use is the dual intercept method. Even though it's not part of the exercise, we're going to sketch this straight line graph using the table method for these values of x, and then we're going to also sketch it using the dual intercept method. The exam will not specify which method to use. The method you use is up to you. So the first thing we're going to do is we're going to draw up a table. Obviously, you're going to use a ruler for this. We want the table to be neat. Y equals 2x minus 5. They've given us a range of values for x between 0 and 5. We're going to choose integer values. We're not going to worry about any other value other than an integer value. So we're going to start the integers between 0 and 5. We'll start with 0, and then 1, 2, 3, 4, and 5. This inequality, that over there, that inclusive sign means that we include 0 and 5. Right? So we've included 0 and 5. So just list the x values in the table. And then we substitute in turn these x values into the expression. So the first x value is 0. So y equals 2 times 0 minus 5, which is minus 5. So we place that y value underneath the x value in the table. Then y equals 2 times 1 minus 5. 2 minus 5 is minus 3. Put minus 3 under 1. And then y equals 2 times 2 minus 5. 4 minus 5 is minus 1. Should immediately be, you can see a pattern over here. We are adding 2 to every y value. So you can just carry on adding 2 to the rest of the values. So minus 1 plus 2 will be 1. 1 plus 2 is 3. 3 plus 2 is 5. We're just going to check that. Very easy to make mistakes. Y equals, the fourth value will be, and x is 3. So 2 times 3 minus 5. 6 minus 5 is 1. Then the next value is x equals 4. 2 times 4 minus 5. 8 minus 5 equals 3. And then the last value is 5. Y equals 2 times 5 minus 5. 10 minus 5 equals 5. We're then going to take these values. If we list this as a coordinate point, x, y, then we'll have 0 minus 5, 1 minus 3, etc. X equals 0 is at the origin, and y is minus 5. Because y is negative, we move down. So down to minus 5, and there's our first point. We're going to call that A. We'll just label this A. The next point, x equals 1. So we go to 1 on the x-axis, and then we have to move down to minus 3 on the y-axis. So we start at 1, and we go down to minus 3. And that's point B. The next point is 2 minus 1. So 2 on the x-axis, and then down to minus 1. That's point C. And then x equals 3, y equals 1, positive 1, so now we're moving up. So 3, move up 1 unit, and that's point D. X equals 4, y equals 3, so we go to 4 on the x, up to 3, and that'll be point E. And then finally, the point 5, 5, x equals 5, and y equals 5. So 5 on the x, move up to 5 on the y, and that's point F. And now we just draw a straight line through those points, and again you're using a ruler and a pencil. Note that when we draw a straight line, we're going to extend this line as far as possible for as large as the grid paper, the graph that you're working on. So the line does not have to extend beyond the grid itself, but it also mustn't just be from point A to point F. Okay, and what we do is we also put arrowheads at the end of the line, and that is to indicate that the line continues indefinitely. Above to the right is to positive infinity, and to the left and below is to negative infinity. So this line extends to negative and positive infinity, indicated by the arrows. We're now going to sketch the same function, but using the dual intercept method. So the dual intercept method, we're working with the intercept of the axes, the x-intercept and the y-intercept. We plot those 2 points and then we draw a straight line through them. So we're going to start with the x-intercept. The x-intercept is where y equals 0. So we put y equal to 0 in the function. So 0 equals 2x minus 5, and we solve for x. 2x equals 5, x equals 5 over 2. Again, we're not going to write this as 2.5 or 2.5. It's 5 over 2. So we'll call this point A. The x value is 5 over 2, and we said that y was 0. This is a point. It is a point, so we list it as a point. We write it as the x coordinate first and then the y coordinate. And then the y-intercept is when x equals 0. So in the function, we are going to make x 0. So y equals 2 times 0 minus 5. Y equals minus 5. As a point, we write x first and then y. The x was 0 and y is minus 5. It's a point, enclose it in brackets, and we're going to call this point B. So now we just have to plot these points. 2.5, 0 is going to be there. And 0 minus 5, 0 minus 5 is here on the y-axis. That's point B. And then we take our ruler and draw a line through them, and we extend that line as far as possible. And as you can see, the dual intercept method is far easier and quicker to sketch not just linear functions, but any other functions that you are going to come across in future. Whether you use the table method or the dual intercept is up to you. Just looking ahead with more complex functions, the table method won't always be possible, but it's also very time consuming. But since this is fairly new to you, you can use either method. Draw the graph of y equals x over 2 minus 3 for x is a value between 0 and 10. Again, we're going to start with the table method, and then we're also going to sketch this straight line graph using the dual intercept method. Okay, so with the table method, we're going to draw up the table. Now they have given us, if you take integer values, so you can have 10 integer values, we don't need all of those values. You really only need 3 points. 5 points is nice. Any more is great. It's lovely, but you don't need to plot 10 points. So we're just going to plot 5 points here, and we're going to choose which 5 points to use. Y equals x over 2 minus 3. We're going to start with 0 because we're starting with 0 here. A 0 divided by 2, we're just looking at this x over 2. We're not going to worry about the rest of the function just yet. We just want to get a nice value for x over 2. So 0 divided by 2 is going to be 0. The next value we're going to use is 2, because 2 divided by 2 gives us 1. Then we're going to use 4. Then we're going to use 6. And then we're going to use 8. You can use 10 if you like. It's not going to make a difference. We've got 5 points here, and that's all we need for the straight line graph. So it's just a suggestion that you use these even values of x because we're dividing by 2, which means we're going to get an integer value for y. So y equals x over 2 minus 3. So when x equals 0, we're going to have y equals 0 over 2 minus 3. 0 minus 3 is going to be minus 3. So the first y value will be minus 3. Then we're going to have y equals 2 over 2 minus 3. That's 1 minus 3, which is minus 2. So the second y value is minus 2. Then y equals 4 over 2 minus 3. That's going to be 2 minus 3, which is minus 1. You can already see a pattern developing here. We are adding 1 to the y values, but we're going to check them regardless. Then the next value is y equals 6 over 2 minus 3. 3 minus 3 equals 0. And finally, y equals 8 over 2 minus 3. 4 minus 3 equals 1. You can see that we're adding 1 to all the y values here. Now we just plot these points. So the first point, x equals 0, and y equals minus 3. So we go down to minus 3 on the y-axis. Call that point A. And then x equals 2, y equals minus 2. So x equals 2, y equals minus 2. Call that B. X equals 4, y equals minus 1. So 4 minus 1, point C. Then 6, 0. So that is on the x-axis over there. That's point D. And then 8, 1. So 8, 1. We'll call that point B. Now we just take a ruler and draw a straight line through those points. And we extend this line as far as possible, remembering to put the arrowhead at the end of the line segment to indicate that the line continues indefinitely to the left and to the right. We're now going to use the dual intercept method to sketch the same line. So y equals x over 2 minus 3. So we first start with the x-intercept and we put y equal to 0. 0 equals x over 2 minus 3. X over 2 equals 3. Multiply both sides by 2. X equals 6. So because it's a point, x comes first, then y. X is 6. Y is 0. And we'll call that point A. That's our x-intercept. So we can just plot that. And then the y-intercept, when x equals 0, y equals x over 2 minus 3, y equals 0 over 2 minus 3, y equals minus 3. Again, it's a point, x first, then y, x equals 0, y equals minus 3. It's a point, so enclose it in brackets, we'll call that point B. So 0 minus 3 is over there. And now we just connect those 2 points. And again, arrowheads at the end of the line, indicating the line continues to positive and negative infinity. On the same set of axes, draw the graphs of y equals 3x minus 2 and y equals 2x plus 1 for x between 0 and 5. And then determine at which point the two lines intersect. Okay, so the first thing we're going to do, we're going to again sketch these two straight line graphs using the table method, and then we're going to do the same thing with using the dual intercept method. It's important that you know how to use both methods. We've chosen integer values 0, 1, 2, 3, 4, and 5 for both graphs, and now we just plot these points. So we're starting with the first function, y equals 3x minus 2. We're going to plot the point 0, minus 2. So we start at the origin, 0, and then we go down 2 units because y is negative. So we go down to negative 2. Plot the first point. Then 1, 1, x is 1, y is 1. X is 1, y is 1. X is 2, y is 4. X is 2, y is 4. X is 3, y is 7. X is 3, y is 7. And then we've got points 4, 10. The graph only goes up to 8 on either axis, so it doesn't really matter. We've got at least 3 points. We've got 4 points here. We're now going to draw a straight line through them. And again, make sure that we extend the graph, the straight line, as far as possible. You've gone over the grid, it doesn't matter. Just make sure that you put the arrowheads on either end of the line segment to show that the graph, the function, continues indefinitely. Okay, then for the next graph, y equals 2x plus 1. The first point is 0, 1. So we started 0 and then we wrote 1 on the y-axis. 1, 3. X is 1, y is 3. X is 1, y is 3. X is 2, y is 5. X is 2, y is 5. X is 3, y is 7. X is 3, y7, and then 4, 9, x is 4, 9 is up there. Again, we've got the 4 points. We don't need more than that. Now just note that these x values have been restricted. X is a value between 0 and 5. This is known as a restricted domain. We're not going to get into domain and range right now. That's not what we are going to get involved with right now. So the fact that I'm putting arrowheads at the end of every single line, strictly speaking, the domain's been restricted. So the graph will only go from where x equals 0 to x equals 5. So we're only going to have the function starting where x equals 0 and ending where x equals 5. But I mean, for all intents and purposes, start getting used to putting arrowheads at the end of functions, whether they're straight lines, quadratic functions, or whatever. The restricted domain just means that we're going to, and I'll sketch the graph strictly speaking as it is, but for all intents and purposes, we're learning how to sketch straight line graphs here using the table method and the dual intercept method. That's the skill that we're learning right now. The technicalities we'll get into later. So strictly speaking, for this domain x less than or equal to 5, greater than or equal to 0, we're only going to sketch the points that we have here. And again, we could have picked any number of points in any number of x values between 0 and 5. The crux of the problem is that we do not go beyond x equals 5. So this is where we stop on the x-axis. We only sketch the graph between x equals 0 and x equals 5. X equals 0 at a and b, and x equals 5 at points C and D. So this is, strictly speaking, how you would sketch the straight line graph. It's a line segment between A and D, B and C. But even if this is just what is called a domain, when the domain is restricted, we do not have arrowheads at the end of the function. All the arrowheads mean is that the function will continue indefinitely. The fact that we've restricted the domain means that it's restricted. It doesn't continue indefinitely. So that's the only technical difference between the graphs that we sketched and this one over here, is that this is finite because the x values have been restricted. Okay. At which point do the two lines intersect? Well, clearly we can see from the graph that the two lines intersect at that point over there. Let's call that point E. And point E is, this is how you write a point, x coordinate first and then y coordinate, 3, 7. We could have also seen the point of intersection by looking at the common term amongst the common point, rather, not the common term, the common point amongst the two graphs. X equals 3, y equals 7. And again, we always list it as a point, so we list it like this. All points are listed as illustrated. Pair of parentheses brackets, x with an x coordinate and a y coordinate separated by a semicolon. We're now going to use the dual intercept method, so we'll start with y equals 3x minus 2. The x intercept is when y equals 0, so we put y equal to 0. 0 equals 3x minus 2. 3x equals 2, x equals 2/3. Okay, this is a fraction, so it's going to be tricky to plot that. It doesn't really matter. So the point is 2/3 0, and we'll call that point A. Then the y-intercept, x equals 0. So y equals 3 times 0 minus 2. Y equals minus 2. Points are always listed with the x coordinate first, which is 0. We chose 0 here, and then minus 2 is the y coordinate. We're going to call this point B. Now we're just going to plot these 2 points and put a straight line through them. So 2/3 0. So we're just going to estimate now. If you've got a more accurate graph, it would be easier to work with. It would just say that that is 2/3 0, and then 0 minus 2 is there. And we put a straight line through those 2 points. But remember that the domain is restricted, so it won't go beyond x equals 5, and it won't, and the function will start at this point over here, right? That's because we have to take this concept, that we have to consider that domain restriction. And then we do likewise for the other graph. Y equals 2x plus 1, x-intercept, y equals 0, so 0 equals 2x plus 1, 2x equals minus 1, x equals minus a half, so the x coordinate is minus a half, the y coordinate is 0, and this is your point. We'll call that point C. And then the y-intercept when x equals 0, y equals 2 times 0 plus 1, y equals 1, x coordinate first, which is 0, then y, and this we will call point D. So minus a half 0 is round about there, 0, 1 is here, and then we put a straight line through those 2 points. Then just remember that the domain has been restricted, so we can only go up to where x equals 5, and we start with x equals 0. X equals 0 is here, this point D, so we're not actually going to be plotting C. But again, this is just a technicality, right? Because the domain's been restricted. What you need to be concerned about now is using both the table method and the dual intercept method to sketch straight line graphs. That's the skill that we're trying to master over here. We're not concerned at this point with technicalities. On the same set of axes, draw the graphs of y equals 3x plus 1 and y equals 3x minus 2. Okay, I'm going to leave the table method for you to do. Choose 5 values of x, and then find the corresponding values of y, plot the 5 points, and draw a straight line through those 5 points for each graph. To draw the graphs here, we're going to use the dual intercept method. I think it's important that you get used to the dual intercept method without any restrictions. You'll notice this question 9 from the textbook actually does have a restriction on the domain. I've removed that restriction because it's just it doesn't affect the problem in any significant way. So I've left it out so we can get used to sketching graphs with the dual intercept method. So starting with y equals 3x plus 1, the x-intercept when y equals 0, so 0 equals 3x plus 1, 3x equals minus 1, x equals minus a third, so the point is, the x-intercept is minus a third 0, we'll call that point A. The y-intercept is when x equals 0, y equals 3 times 0 plus 1, y equals 1, so the y-intercept is 0, 1, and we'll call that point B. Then for the second function, y equals 3x minus 2, the x-intercept when y equals 0, 0 equals 3x minus 2, 3x equals 2, x equals 2 thirds. So the x-intercept for the second function is 2 thirds 0. We'll call this point C. Again, we have fractional values here. It doesn't matter, you're just going to have to adjust the intervals on the axes that you draw up. The y-intercept, x equals 0. So y equals 3 times 0 minus 2. Y equals minus 2, so the point is 0 minus 2, and we'll call this point D. Now all we're going to do is plot points A, B, C, and D, and put a straight line through A and B, a straight line through C and D. So these are the two functions that we've sketched. Y equals 3x plus 1 and y equals 3x minus 2. Do the two lines intersect? If not, why not? Well, we've just sketched them. We can clearly see that they do not intersect. These lines are parallel. Why are they parallel? If we look at both of these functions are in standard form, y equals mx plus c form. And as done previously, to find the gradient of a line, we write the straight line function, linear function in standard form, y equals mx plus c form. So the gradient of the first line is 3, and the gradient of the second line is also 3. These lines are parallel precisely because their gradients are equal. So the two lines are parallel because they have the same gradient. So obviously they do not intersect. Okay, a line has equation y equals 1.5x plus 3. This is not a nice way to write functions. We're going to write 1.5 as 3 over 2x plus 3. This is a much better way to write any algebraic expression, is to not have decimals. Be that as it may, decide whether each of these points is on the line or not. Okay, if a point is going to lie on a line or a function, then when we substitute its x, taking a point, we substitute its x coordinate into the function. If the corresponding y coordinate equals the point that we've, the y coordinate of the point that we were given, then that point would lie on the line. So in other words, if we take the point 6, 12 and we substitute it into the function y equals 3 over 2x plus 3, we take the x value and we substitute it in for x, then we'll have 3 over 2 times 6 plus 3. That'll be 3 times 3 is 9 plus 3 is 12. The fact that we get 12 here and 12 is the y coordinate, that means that this point does lie on that function. Next example, and we're not going to use 4.5 here, we're going to use 9 over 2. So y equals 3 over 2x plus 3. Using decimals is just going to encourage you to use a calculator, and that's what we're trying to get away from, right? We're not using calculators for simple calculations like these. So substituting x equals 0 into the function, we'll get 3 over 2 times 0 plus 3. 0 plus 3 is 3. The fact that we get 3 here, but the y coordinate is 9 over 2, that means that this point does not lie on the line y equals 3 over 2x plus 3. And that's what you're going to be doing for the rest of the exercise. We'll do one more. Y equals 3 over 2x plus 3. Substituting x equals 2. 3 over 2 times 2 plus 3. That'll be 3 plus 3, which is 6. The fact that we get y equals 6 after from substitution, and the y coordinate of the point is 6, that means that this point 2, 6 does lie on that line. Let's just do one more for completeness sake. I'll leave E and F for you to do. Point 10, 13, y equals 3 over 2x plus 3. Y equals 3 over 2, substituting x equals 10 in. 3 over 2 times 10 plus 3. 30 over 2 is 15. 15 plus 3 is 18. So we get 18, but the y coordinate is 13. That means this point does not lie on the function. You don't answer questions like this in an exam. If you get a question like this with a tick and a cross, you're actually going to write it out. This point does or does not lie on the line. Okay, given the graph y equals 2x minus 7, use the graph to solve these equations. 2x minus 7 equals 5. 2x minus 7 equals 0. 2x minus 7 equals minus 3. Okay, if we were not given a sketch graph like this, and we were just given that, you would use a simple linear equation. You would isolate the variable term, and you would solve for the variable. But we're going to be using, and we'll solve it that way as well, but we're going to be using the graph to solve these equations over here. So y equals 2x minus 7. So essentially what they are saying here If we just wrote this as y equals 5, y equals 0, and y equals minus 3, all that means is we go to these values 5, 0, and minus 3 on the y-axis. We then move horizontally across to the straight line graph, and where we meet the graph, we then drop a perpendicular down to the x-axis, and we just read off the x value. So if we're starting at y equals 5, so we're starting at y equals 5, which is here. We are then going to move across with the ruler to the function, which is at that point there, point A, and then we drop a perpendicular down to the x-axis. So for y equals to 5, x equals 6. Right? That's done graphically. Now before we do B and C, let's solve this like we normally do. Algebraically, 2x minus 7 equals 5. You take the minus 7 across because you want to isolate the x term. 2x equals 7 plus 5 is 12. Divide both sides by 2, and x equals 6. So we've solved this equation algebraically and graphically. We're just learning a new skill here. Linear equations are not new to you. We're just learning to solve linear equations graphically. Okay, now we're going to solve for x where y equals 0. So y equals 0 is here at the origin. We're then going to move horizontally across until we meet the line, which is at that point over there. Even though it's not indicated on the graph, it's directly between 3 and 4, which is 3.5. So x is 7 over 2. Again, we are not writing this as 3.5. We're not writing it as 3.5. We no longer use mixed numbers or decimals at grade 10 level. We're using only fractions. So we're writing 3.5 as 7 over 2. Now let's solve this algebraically. So 2x minus 7 equals 0. We take the minus 7 across. 2x equals 7. Divide both sides by 2. X equals 7 over 2. And then we have the solution algebraically and graphically. And finally, we're going to solve for x when y equals minus 3. So we go to minus 3 on the y-axis, which is there. We move horizontally till we meet the function at that point there, and then we move up to the x-axis, which is at 2. So y equals minus 3 and x equals 2. X is 2 and y is minus 3. Let's solve it algebraically. 2x minus 7 equals minus 3. Take the minus 7 across. 2x equals 7 minus 3, or minus 3 plus 7, which is 4. Divide both sides by 2, and x equals 2. So there's the solution algebraically and graphically. Okay, this is a similar question. Y equals 0.5x plus 15. Again, this is an ugly way of writing the equation. We're going to write it with the 0.5 as a half x plus 15. So what this is essentially saying here is y is a half x plus 15. This is a half x plus 15 equals 25. So what it's essentially saying is, what is x when y equals 25? So we go to 25 on the y-axis, move horizontally across to the line, to the function, meet the line, and then drop a perpendicular down to the x-axis, which is at 20. So x equals 20. Now let's solve it algebraically. A half x plus 15 equals 25. We take the 25 across. So a half x equals 25 minus 15 equals 10. Multiply both sides by 2, and therefore x equals 20. So we get the same answer algebraically and graphically. B, we are essentially saying a half x plus 15 equals 10. We're saying that y equals 10. So we go to where y equals 10 on the y-axis. Now we're moving left because we have to meet the line. So we move horizontally until we meet the line, which is at that point there. Drop a perpendicular down, and we get minus 10. So x equals minus 10. And again, we're going to solve this algebraically. So a half x plus 15 equals 10. We take the 15 across. A half x equals 10 minus 15 is minus 5. Multiply both sides by 2, and x equals minus 10. So we get the same answer algebraically and graphically.